You can have data without information, but you cannot have information without data. Good morning to one and all present here. On behalf of Lal Bahadur Shastri Institute of Management Delhi, I, Simran Bhutani, a PGDM first year student, feels greatly honored to welcome you all for this year's international seminar, Big Data Analytics for Industry 4.0 Applications and Challenges. I take this opportunity to thank you all for gracing this occasion with your august presence. For decades, humanity envisioned and dreamt of a technology-enabled future, one with autonomous transportation, flying vehicles, a clean and a safe environment, and a healthy extended life. Industry 4.0 is the fusion of the real world with the virtual world. This digital revolution is marked by technology that takes advantage of big data and artificial intelligence to nurture automatic learning systems. Big data is the upcoming major thing of the high-tech business. The innovation and research directed by the best tech companies are affecting industry verticals such as healthcare, auto, finance, retail, and manufacturing. Today's seminar, through the deliberation by people management experts, explores the theme of the International Seminar 2021, Big Data Analytics for Industry 4.0 Applications and Challenges. Before we start, let's take a moment to remember the man whose dreams and aspirations motivated others to work towards the common goal of the nation. The man whose basic idea of governance was to hold the society together so that it can develop as a whole and march towards a common goal. The man of masses and India's great son, late Sri Lal Bahadur Shastri.
सत्ताईस मई 1964 पंडित जवाहरलाल नेहरू का निधन हो गया। देश गहरे विषाद में डूब गया। सभी के मन में एक ही सवाल था, कौन बनेंगे नए प्रधानमंत्री, कौन करेंगे इस महान सभ्यता का नेतृत्व।
आफ्टर नेहरू के बाद कौन होगा, तो ये उनको इस बात का एहसास था। जब मुझसे पूछा गया कि इस कमी को दूर कैसे करेंगे, तो उन्होंने कहा कि पंडित जी ने अपने व्यक्तित्व की वजह से, टावरिंग पर्सनैलिटी की वजह से, उन्होंने इस पद को शक्ति प्रदान की और मैं प्रयास करूंगा इस पद से शक्ति प्राप्त करने की, जिससे कि मैं देश की सेवा कर सकूं।
2 अक्टूबर 1904 के दिन काशी के पास मुगल सराय में जन्मे लाल बहादुर का पूरा व्यक्तित्व ही गांधीवाद का जीता जागता स्वरूप था।
उनकी सादगी, पहली बात तो धोती पहनते थे। ये आम आदमी को उससे बड़ा भरोसा हो जाता था कि हमारे जैसे है।
पिता की छत्र छाया बचपन में ही छिन गई थी। विधवा मां के साथ ननिहाल चले गए, वहीं पर परवरिश हुई। 1920 में जब स्वतंत्रता आंदोलन में कूद पड़े तो निष्ठा और दृढ़ता के प्रमाण मिलते चले गए। 17 वर्ष की आयु से स्वाधीनता तक लगभग 9 साल जेल में काटे। रहीमन हीरा कब कहे लाख टका मेरो मोल। पार्टी कार्य में उनकी निष्ठा से प्रभावित होकर नेहरू ने लाल बहादुर शास्त्री को रेल मंत्री नियुक्त किया, परंतु 1953 में घटी एक रेल दुर्घटना की नैतिक जिम्मेदारी लेते हुए शास्त्री जी ने मंत्रालय से इस्तीफा दे दिया।
उन्होंने वो इस्तीफा देकर राजनीति में नए मूल्यों की स्थापना की।
नेहरू जी के मंत्रिमंडल में कई विशिष्ट पदों पर अपनी छाप छोड़ते हुए वे गृह मंत्री नियुक्त हुए। 9 जून 1964 पंडित नेहरू के निधन के बाद स्वयं पंडित नेहरू के चहेते लाल बहादुर शास्त्री ने भारत के दूसरे प्रधानमंत्री का पदभार संभाला। कुल 4 शब्दों में उस मृदुभाषी व्यक्ति ने देश को एक नारा दिया, जय जवान जय किसान।
उन्होंने उस समय इस बात का एहसास कर लिया था, देश के अंदर हमें अपने जो भंडार है अनाज के उन्हें पूरा भर देना है और एक जो भारत के गौरव और गरिमा को देश विश्व में खड़ा कर देना है, वो अगर संभव है तो जवानों और किसानों की जय जयकार करने से ही है।
लाल बहादुर शास्त्री, प्राइम मिनिस्टर ऑफ इंडिया, स्पीकिंग ऑन इंडिपेंडेंस डे इन 1965।
हम हथियारों का जवाब हथियारों से दें।
5 सितंबर 1965 पाकिस्तान ने भारत के खिलाफ खुली जंग का ऐलान कर दिया। जवाब में भारतीय सेना पंजाब से सीमा पार कर गई। जब तक संयुक्त राष्ट्र की पहल पर युद्ध विराम हुआ, तब तक भारत की सेनाएं पाकिस्तानी सेना पर हावी हो चुकी थी।
वो किसी के दबाव में आने वाले व्यक्ति नहीं थे। जब ऐसी घटना होती है तो बहुत ज्यादा अंतर्राष्ट्रीय दबाव होते हैं। अगर आप दब गए तो झुक जाएंगे, वो नहीं दबे। लेकिन फिर शायद दोनों देशों की भलाई सोचकर वो युद्ध विराम पर राजी हो गए।
10 जनवरी 1966 ताशकंद। जिन आदर्शों के नैतिक बल का मजा वो पाकिस्तान को चखा चुके थे, आज उन्हीं आदर्शों की उदारता से उन्होंने समझौते के कागजात पर दस्तखत कर दिए। लेकिन अभी समझौते के दस्तावेज पर स्याही सूखी भी न थी कि उसी रात शास्त्री जी को दिल का दौरा पड़ा और उनकी मृत्यु हो गई। गांधी जी ने कहा था कि शत्रु का दिल जीतना ही वास्तविक जीत है। सुदूर ताशकंद में जब स्वर्गीय लाल बहादुर शास्त्री को कोसिजिन के साथ साथ खुद जनरल अयूब खान ने कंधा दिया, तो लगा जैसे शास्त्री जी बापू के फलसफे को चरितार्थ कर दुनिया से रुखसत हो गए थे। लाल बहादुर शास्त्री केवल 18 महीनों तक भारत के प्रधानमंत्री रहे, लेकिन अपने प्रधानमंत्रित्व के छोटे से कार्यकाल में शास्त्री जी ने भारत के हर नागरिक के कानों में आत्मसम्मान और आत्मबल का मंत्र फूंक दिया था। अपने व्यक्तित्व से उन्होंने निष्काम कर्म और पुरुषार्थ की वो मिसाल कायम की कि उनकी गिनती भारतीय इतिहास के सर्वोच्च महापुरुषों में होती है।
Following the tradition of Lal Bahadur Shastri Institute of Management, Delhi, I request Professor Praveen Gupta sir, Director LBSIM, Dr. Sandhya Makkar, Seminar Convener, Dr. Balram Tyagi, Seminar Co-Convener, Dr. Rajkumari Mittal, Seminar Co-Convener, Colonel Ajay Sood, Chief Administrative Officer, and Mr. Ankit Kumar, President Management Grid, to offer floral tributes to late Shri Lal Bahadur Shastri ji. Moving on, I would like to take this opportunity to introduce our esteemed director, Professor Praveen Gupta. Professor Gupta has more than 3 decades of experience in industry, teaching, academic administration, and corporate training. Before joining LBSM Delhi as the director, he has held many significant positions at the institute, specifically spearheading projects relevant to institutional vision and endeavors. So, may I now request you to kindly deliver the welcome address and to officially set today's conference open. Please, sir.
Good morning, everyone. Distinguished speakers for the day, conference convener Dr. Sandhya Makkar, colleagues from Operations and Business Analytics domain, Chief Administrative Officer Colonel Ajay Sood, faculty colleagues, and students. It is indeed a great day of satisfaction and privilege that we are holding this seminar, which is very aptly titled Big Data Analytics for Industry 4.0. The world is changing at a very fast pace. Industry and its working has undergone tremendous change, and more so with the advent of technology, and more so with the advent of benefits of big data analytics. But let me caution our students on one aspect. It is extremely important for you to understand the fundamentals of business. You all aspire to ride on the wave of business analytics. You must learn the essentials. You must learn the essentials of big data and big data analytics. But you must also learn what is business. The essence of business remains the same. The pace has changed. What is essence of business? Essence of business is same which was defined few decades ago. Identifying customers' needs and evolving your product and services around that. And how can we deliver and communicate the same product and service which gives a superb experience to the customer better than the competitor? This is the essence of business. Suppose you acquire reasonable, you can say, skills for data analytics. What is the difference between a data analyst and the chief data analyst at a business? The person should be able to cater to the client's needs. They should understand the client's requirement. They should understand the competitive forces. There will be domain experts during the discussions. They will apprise the developments which are taking place in this area. How Industry 4.0 is different from, say, other three phases, especially Industry 3.0. There is connectivity, there is interdependence, there is globalization, there is, I'll say from Six Sigma, you are aiming zero defect. There is huge importance of optimization. Optimization in terms of resources, optimization in terms of pricing, optimization in terms of right product at right place at right time. And you have to beat the competition. If you have a similar product and similar service, that will not take you far. You have to beat the competition. You have to beat the competition in terms of product quality. You have beat the competition in terms of pricing. You have to beat the competition in terms of customer experience. I was reading and it was astonishing. On one assembly line, 70 terabyte kind of data is generated in today's manufacturing. Now, data itself is of no use unless and until it is analyzed and put to the rightful use. So that is the responsibility of today's generation. Say a century ago, it used to be what is meant by education. It was 3 R's: reading, writing, and arithmetic. Then it became, say, more focus on science. And as the civilization grew, there was more focus on social sciences also. I think focus has gone back to arithmetic, statistics, and science. So let me encourage our students and inspire them that you are at the right place. We have a program, PGDM Research and Business Analytics. So what better choice for you as a career than R&BA? Similarly, we are going to introduce PGDM Artificial Intelligence and Data Science. So the importance of data science is growing day by day. But you have to work hard. And there is another message for my students from PGDM General and PGDM Finance. You have ample of opportunity in the institute in terms of softwares, in terms of databases, and in terms of faculty. Choice is yours. This is your career, your life. If you are in second year, I'll say you have 4 months, 5 months with us. If you are in first year, you have another full year with you. You have to make best use of these days. Again, some the same, right? Success is still 99% perspiration and maybe somewhat inspiration. So you have to perspire, you have to work hard. What is your say level of aspiration? That will decide your future. And let me say, if you do not do justice to your arithmetic and statistics and science, maybe history will punish you. So you have a lot of choices. You have to make right choice. Already you have made a right choice by joining, say, LBSIM and Research and Business Analytics. But the kind of perspiration which I want to see is not there. Secondly, again, I'm repeating, please do not miss the essence of business. If you miss the essence of business, your growth in business analytics will be limited. All people who work at the top position, they understand the nuances of business and the needs of the customers. So let's use this opportunity for today's seminar. There are domain experts. They will be sharing their experiences. They'll be sharing their knowledge. Draw enough inspiration and motivation from them and put them to use. Thank you so much.
Thank you, sir, for your motivating words. Now, I would like to introduce Dr. Sandhya Makkar, the seminar convener. Dr. Sandhya Makkar is working as an area chair of Operations and Business Analytics at Lal Bahadur Shastri Institute of Management. She has more than 15 years of academic and research experience in management science, supply chain, machine learning, and optimization techniques. She has also conducted various faculty programs and management development programs on predictive analytics and optimization techniques. I request Sandhya Makkar ma'am, seminar convener, to apprise us about the theme of the seminar. Please, ma'am. In management science, supply chain, machine learning, and optimization techniques. She has also
A very good morning to all honorable speakers from different parts of the globe. Professor Praveen Gupta, Director LBSIM, Colonel Ajay Sood, Chief Admin Officer, seminar conveners Dr. Balram Tyagi, Dr. Rajkumari Mittal, Dr. Sugandha Agarwal, Mr. Ankit, President Management Grid, delegates, faculty colleagues, students, and guests present both online and offline. It is my privilege to welcome you all to International Seminar on Big Data Analytics for Industry 4.0, Applications and Challenges, and to introduce the topic of today. Data analytics is the future, and the future is now. Every mouse click, keyboard button press, swipe, or tap is the use to shape business decisions. Everything is about data these days. Big data, data analytics, data mining, it seems everywhere you turn. There is a talk of data, but there seems to be a less discussion of what data is, what you can do with it, and how it relates to the real world. Now, more than ever, data is taking a center stage as we move further into what experts are titling the fourth industrial revolution or Industry 4.0, and some say that the data and the byproducts of gathering and analysis of the data is the fourth industrial revolution. Let's unpack this a bit by going back in time. The first revolution was titled the Industrial Revolution, which used steam power to automate factories and travel. The second revolution introduced electricity as means to accelerate industry. The third included the adoption of computers, robotics, and the internet. Industry 4.0, or the fourth revolution, involves harvesting the information, that is data, that comes from sensors, aggregators, cloud computing, and the Internet of Things, to name a few, and making sense of them to create more profit and run companies, factories, and organizations more efficiently. The advanced technologies that evolved because of fourth industrial revolution have severely disrupted industry and society by connecting processes and systems that were previously unconnected, creating new insights and innovations, and the rise of artificial intelligence. Efficiency and increased profits are not only the advantages of adopting an Industry 4.0 model. Data-savvy companies are more competitive and are able to identify problems before they become an issue. The struggle to use data efficiently, however, is great. According to Forbes, almost 95% of the companies globally cite that unstructured data is one of their greatest challenges. However, companies who adopted Industry 4.0 practices early reported greater resilience to crises, including COVID-19 pandemic, with 65% of the respondents to a recent McKinsey study saying that their perception of the value of Industry 4.0 was heightened since March 2020. There is no doubt the fourth industrial revolution is most disruptive to date. But to most of us, there are still many questions that hover our mind, like how do organizations use the data they collect? If data analytics is so great, are there any downsides? Who is Industry 4.0 right for? What are the benefits of adopting Industry 4.0 model? What are the challenges to consider and overcome? And many more. To answer these questions, today in this seminar on Big Data Analytics for Industry 4.0, Applications and Challenges, we have with us industry experts, global speakers, academicians, and researchers who will provide insights on a number of real-time issues, problems, and applications with corresponding solutions and suggestions. The aim of the seminar is to share the new theoretical and applicative tools and techniques for Industry 4.0 that will offer a valuable asset for newcomers to the field and practicing professionals alike. I am grateful to the speakers of today for accepting our invite to be the part of this seminar. I once again extend a hearty welcome to all and wish everyone to enjoy the thought provoking sessions. Thank you.
Thank you so much, ma'am. So now we will commence our today's session on big data analytics for Industry 4.0 applications and challenges. All of us are looking forward to the enriching discussion lined up ahead.
Moving forward, I would like to introduce our first speaker, Dr. Arindam Pal. Dr. Arindam Pal is a senior research scientist at Data 61 in Commonwealth Scientific and Industrial Research Organization and a senior research fellow at Cybersecurity Cooperative Research Centre, Australia. Dr. Pal is also a conjoint senior lecturer at University of New South Wales, Sydney. He has worked with many organizations such as TCS Research and Innovation, Yahoo, IBM, Cognizant, and Microsoft Corporation. Dr. Pal earned his PhD in Theoretical Computer Science from the Department of Computer Science and Engineering, Indian Institute of Technology, Delhi, and completed his Masters of Engineering from the Department of Computer Science and Automation from Indian Institute of Science, Bangalore. His primary areas of expertise are artificial intelligence and machine learning. Sir, it's an honor to have you with us today. I welcome you to kindly share your views with the audience.
Thank you. Thank you for I first thank the organizers for inviting me, and in particular Dr. Shonda. Let me first share the slides. Can you?
Yes, sir, it's visible.
Okay. Of course, this is a very important event, and first of all, I would like to thank the organizers for the event. I respect and admire Sri Lal Bahadur Shastri very much. He was very honest and like a common man. I mean, who was very simple and down to earth. So I have a lot of respect for Sri Lal Bahadur Shastri, and it's great to see that this institute is named after such a great man. And this topic is also very relevant for today's world, the big data analytics for Industry 4.0. So today, I'm going to talk about this detecting phishing websites, a tale of algorithm. So this is a joint work with my academic collaborators from UNSW Sydney. So it would have been great if I could be present physically in New Delhi and give in person and interact with all of you. My PhD from IIT Delhi. Maybe I mean I finished in 20. I was there for 5 years, 2012. So IIT Delhi is in Hotchkiss, which is not very far from the Dwarka where your institute is located. So, but unfortunately, due to the current pandemic situation, both in India and Australia, we are having a lot of difficulties in traveling. So hopefully, next time when I have the opportunity, I'd love to visit your place. So before starting, first I would like to acknowledge the traditional owners of this land where I am sitting in Sydney, the Gadigal people and their elders, past and future. So here is the agenda for today's talk. So, so phishing is a very important problem, both in terms of cybersecurity and from machine learning perspective also. So this is like a very important problem in terms of like which sits at the intersection of data science and cybersecurity. So, and as you see, it's a difficult problem also. It's a very challenging problem, and there are many reasons why it's very challenging. So basically, what I will talk about today is first I will define what is phishing. Then I'll discuss why phishing is so difficult to detect and prevent. So then I'll briefly introduce different approaches for detecting phishing websites. Then we'll discuss briefly about two machine learning algorithms for detecting phishing websites. The first one is called Phishing, which is a novel using a compression algorithm. And the second one is Phishing, which is a similarity-based method to detect phishing websites. I'll compare our algorithms with other phishing detection methods and see what are the benefits of our method. Then I conclude the talk with some pointers for future direction. So please feel free to ask questions if you have any during the talk. So what is phishing? So phishing is the fraudulent attempt to obtain sensitive information or data such as usernames, passwords, credit card numbers, or sensitive details. So the fraudsters typically impersonate themselves as trustworthy people. I'm sure most of you have received many phishing emails, and nowadays even I get phishing SMS messages as well as WhatsApp messages. And even though I do a lot of research on phishing, but I'm not ashamed to tell that I sometimes wrongly think that those are like genuine email. I click on that. So these are very sophisticated attempt to fool people, right? So I'm sure you also have faced, many of you, right? It's such an important problem and it's a menace in concern. But the phishing has grown significantly in the last few years. So as of 2020, so among all the kind of criminal activities done by the cyber criminals, phishing is by far the most common attack performed by them. The Federal Bureau of Investigation Internet Crime Complaint Center says that there are twice as many incidents of phishing than any other type of computer crime. And it is predicted to further increase in the future. In fact, during COVID time, we have seen that phishing has actually increased significantly because, I mean, now most of the transactions and interactions are taking place digitally. So it has given the criminals even more motivations to indulge in this kind of thing. So just in the US, at least United States, at least $2 billion were lost in 2020 due to phishing. So this is a very important problem to detect and take action against. So here is an example of a phishing website. So I took the instance of PayPal because PayPal, in our study, we found PayPal is the number one site which the phishing phishers target or the criminals target. So on the left, you can see there is the genuine website. And on the right, you can see there is a website that has been designed by the cyber criminals. And they have many variations, actually. There is not only one. I have just taken one example of phishing website, but there are many type of replicas of original website that they make. And it's very difficult even for experts to figure out that this is not a genuine website. And that is exactly what we want to do by using machine learning algorithms to detect this. So here is the general phishing scheme. So there is an attacker. He or she sends a message. It can be SMS message, it can be email, or it can be a instant messaging message, for example, on a message on Google Hangout or WhatsApp, and it's sent to the victim. So, and typically there will be a URL in that, and the victim clicks on the URL that redirects the victim to the phishing website. Now, typically on this phishing website, so it can be like it can say it is the site of your favorite bank, for example, ICICI Bank or State Bank of India, or it can be PayPal or maybe your Netflix account or something like that. Right? Typically, you have to put your credentials, the username and password. So but that's not the genuine website. It's the fisher website that the phishing person has set up. Now you input your username and password, and typically the website will give some message like error 404 not found or some such thing, and you think that maybe it was wrong. What the phishing, the criminal has actually done is that he has taken your credentials and he has put it logged into a database, and then they will collect these usernames and passwords, and they will use those credentials to access your account, for example, a bank account or a Netflix account or maybe PayPal account, things like that. And then they will do malicious things. For example, they will try to do this money laundering, or they will try to transfer money from your bank to another bank, or maybe they will try to watch movies without paying for them, and so on. So why is phishing so difficult to detect and prevent? So first of all, it is a low-cost job for the attackers, and it is very difficult to find and prosecute them. Also, there are numerous phishing toolkits exist on the what is known as the dark web, which is typically used by the criminals, like the money laundering and for prostitution or drugs and things like that. The part of the web that is called dark web for criminal activity. So they also sell this kind of phishing toolkits to design phishing websites. And nowadays, even some of them are freely available online. So now, and also the phishers can learn the phishing method, and then they can change the phishing website in response to that. Also, there is another technique they use. So for example, when a search engine or a phishing detection agent, they go to that site, they show them a normal and when the normal user goes, for example, you and I, from a browser, so there is a technique by using the user agent by which they can actually find out whether it's a search engine or a normal user, and they can show the normal user the phishing website. So even for an algorithm, it is difficult to find out whether that's a real website or phishing website, because they can fake that. And it's very difficult. In most, suppose you are trying to optimize something, or you are forwarding, and then typically the objective function that you have, that is constant, right? That's fixed. In this case, this is not fixed, because your adversary is a human, and then he or she is intelligent, right? Based on your algorithm, he is trying to change his algorithm in response to that, and then he wants to beat your algorithms, right? So this is not a fixed target. It is a moving target, and it is very difficult to beat that kind of a system or adversary. So what are the typical challenges? So many times the challenges are not in the systems of the algorithms, but it is in the humans, because typically humans are the weakest link or chain in the system. So typically they use non-ASCII characters, use a visual deception, or they do something what is known as the social engineering. So they maybe pretend that they are your friend, or they are in some distress and they want to get some money from you, and using that kind of your human aspects or your sympathy, by using your sympathy, they try to get some insights into about your username and passwords and things like that. Also, setting up phishing websites are getting easier, because there are a lot of free hosting providers that are available online, and pre-made phishing kits are also available on the, and there are existing tools and methods to automatically generate URL phishing websites, and these are typically short-lived. Like they will say maybe they are for a few hours, and then they gather their credentials and they just vanish. You can detect them because you cannot find that. URLs which you block. Approach, which is typically using machine learning. So they consider different attributes of a website. For example, it can be based on the website content, like HTML, the CSS, or the JavaScript. It can be based on the page hosting information, like the web server that is hosting the page. It can be the URL of a website. It can be the website screenshot images, and many more. I just listed some of the important features, but there are many more features that are considered to detect whether a particular website is genuine or a phishing website. So we are working on this problem for many years now, and till now we have developed at least 2 methods which seems to be quite effective. So so I'll give a brief description of these 2 algorithms. Of course, I cannot get into all the details because they require a lot of time, but I'll give a high-level overview of that. to get you the feel about this. So the first approach is called fish chip, which is basically a novel phishing detection approach using a compression algorithm. And the second algorithm is called phishing, which is a similarity-based method to detect phishing websites. And hence the name, a tale of two algorithms. So here are some of the design goals which we set when we started working on this phishing detection project. So the methods of the algorithm should be conceptually simple because humans should be able to easily understand them. They should be efficient. That means the algorithm should run fast on an input. They should be scalable. That means the algorithm should not only run fast, but it should be also able to run fast and handle a large data set. Okay, so typically these are large data sets that you have to handle, and they should be accurate. So they should be able to detect both phishing websites and non-phishing websites with high accuracy. Now, although these design goals are quite admirable, it is very difficult to achieve all of these things together, because if you try to, for example, want to make something accurate, typically it leads to making the algorithm run for longer time. So these design goals are sometimes kind of goes against each other. I mean, it is very difficult to achieve all of them simultaneously. So here is the high-level idea of the fish chip algorithm. Okay, so it's actually a very simple idea. So we observe that phishing and legitimate websites are compressed differently. So when you run a compression algorithm on these websites, the HTML code of that, and also we noticed the different words and in a genuine or legitimate website, we want to use the phishing optimized model and non-phishing optimized model separately. Phishing optimized model produces a better compression ratio than the non-phishing optimized model, then the website is classified as phishing, and vice versa. If the non-phishing optimized compression model produces a better compression, then it is called it's called non-phishing. So here is a simple picture to understand that. So we have the website HTML content. It's the high-level architecture. So you have, and also have the phishing word dictionary and non-phishing word dictionary that we collected. Then we ran both the compression models, both phishing optimized and non-phishing optimized. Then we compute the compression ratio. And if the phishing optimized compression model produces better compression ratio, we declare this as non-phishing, or we declare this as phishing. If the non-phishing optimized compression model produces better compression ratio, we declare as non-phishing. So that is the website class that we output. So this is a high-level view. And here is our contribution. So basically, we did a systematic process of extracting meaningful words associated with phishing from websites. We came up with an algorithm to perform phishing website detection using the deflect compression algorithm. And also we introduced the use of compression ratio as a novel machine learning feature. So these are some of our contributions. So the components of the systems are dictionary builder, compression-based classification model, and website classifier. So dictionary builder, we calculate the likelihood of words occurring in each website class. It's the characteristic, and then we select a minimum likelihood threshold value. And I can show you what formula we are doing. So there is a probability that we are computing. This probability is based on, suppose we have a particular word under consideration, WK, suppose that word is email, and VJ is the website category. So what we are really doing, we are computing a conditional probability that the email, what is the probability of email given that the website class is, say, phishing, and then we compute that value. Okay. And then we do this kind of conditional probability for all the words and for all possible classes. Now, if we see a diagram, so we did a lot of experimental study also. So you find like on the bottom, it's a bit small, like you have this things like access, account address, and what is the likelihood. So we plotted a distribution which is known as the word occurrence likelihood under the condition that it is phishing or non-phishing. So phishing is kind of blue and non-phishing is orange. Okay. So now, and then we compute the compression ratio of the size of the original versus the size of the compressed version. And then based on that, we did the classification. Now, of course, I cannot go into all the details, but here are some performance metrics that I got, and we compared with many other state-of-the-art algorithms. So one of them is Cantina Plus, which is the state-of-the-art. And you can see that in all the performance ratios like true positive rate, false positive rate, accuracy, and F1 score, Fishchip outperforms Cantina Plus by a lot of margin and typically by a high margin. And also we did the ML model performance using compression ratio as a feature, and we found that if you use compression ratio as a feature, among other things like logistic regression, SVM, decision tree, and random forest actually performs the best. Okay. So again, I don't have time to go through all the details, but here are some results that we got. So of course, if you have question, you can send me email after the talk, and I can give you detailed answer about that. So here is Fishchip in a nutshell. It performs the best performing, outperforms the best performing classifier Cantina Plus with a true positive rate of 80.04%, and using compression ratio as additional feature, EPR improves by 30.3%, and accuracy increases by 11.84%. Okay, so that's the takeaway from this in a nutshell, one slide from the result perspective. Then I next go to the second algorithm, which is probably even more sophisticated. It is called Phishing. So basically, the main idea is that we found many of the phishing websites are variations of other known phishing websites. So that is clear because I told you one of the way phishers do this is by using some toolkits, right? So they start from a template and then they just modify a few things about the website. So based on this idea, we can group phishing websites based on their similarities with known phishing websites. And this can be done using an appropriate distance function and a clustering algorithm. So many of you who are aware of clustering and grouping, so you can see that we can use a distance function to cluster various objects, and that is the idea we use to cluster these websites. So as a distance function, so you know, I mean, whenever you do a clustering in some metric space where you have these objects are like points in the metric space, you need a notion of a distance, right? Because any metric space, the important thing is that you have a function called the distance function, which satisfies certain properties, for example, the triangle inequality, but you need a distance, right? For this particular thing, we use what is known as a normalized compression distance between two strings, and those strings, because the page can be thought of as a string, then you can compute the normalized compression distance between two websites also, because treating them as a string of English words. Okay, now the reason we use normalized compression distance and not normalized information distance, it is a little subtle. Because we are using the Kolmogorov distance complexity of x in NID that cannot be computed. So NCD XY, the normalized compression distance, is really an approximation to the normalized information distance, and that can be computed efficiently. So that's why you use NCD instead of NID. So if you need more details, I can talk offline. I mean, after the talk. So now there are three core algorithms for detecting phishing. So one is the prototype extraction, one is the NCD-based classification. This is the distance function that we use. And the third one is called incremental learning. So again, I'm not going through the details of this algorithm. So these are the algorithms that we have. But what I'll instead do, I'll illustrate this with an example, with a picture that will make it very clear. So basically for each of these, for this data set, we are trying to find out some prototypes which will give a signature of their class or similar blue points. Okay, these are websites. I mean, I don't know whether they are phishing or non-phishing. I want to find out. So then I found, using the algorithm that I mentioned, I found the prototype one. So this is also known as the farthest point fast algorithm. So you are trying to find out that point which is farthest from the prototype. So first I found the prototype 1, then I found prototype 2, then I found prototype 3 using the previous algorithm. And then we do the NCD based class based on the prototypes that I found out in the first round. Okay, so that was my goal of finding the prototype, right? So if you see these things, so we have found these prototypes which are like the solid orange balls or the solid orange circles as they are mentioned in the prototype, and then those which are lying within their circle, you can say circle and closest to that prototype. So that is belongs to that prototype cluster. Okay, the circle. Come up with the incremental algorithm to so you continuously, and we have incremental learning method to detect whether they are phishing or non-phishing. Okay, so it is not just a static thing; it's a dynamic process. So when we compare this with the state of the art, so we compared with quite a few things, and so one of them is known as doc2vec. So for those of you who are aware of this, so this doc2vec is basically a method where you have the set of words, and then you put the words in a matrix space, and then you try to compute similarity between those things. So that is one of the methods that we compared. We also another state of the algorithm called proportional distance, and those things are and also we compared this with fish shim method. I think this should be fish shim, not fish based. Now we found that almost all of the metrics like true positive rate, accuracy, F1 score, and area under the curve score, fish sim is actually performing better than the other state of that algorithm. Only for the false positive rate, the proportional distance is performing better. So in most of the performance metrics, our algorithm fish sim is performing better than the competitors. And also, if you look closely at the area under the curve, so this is called the receiver operating characteristic curve, which is a very important measure in machine learning. So as you can see, we plotted the true positive rate against the false positive rate. And if you zoom into this from this part to zoom in, then you can see that which is the green one, that is generally performing better compared to the rest of the two. Okay. So now we also studied the accuracy and true positive rate using incremental learning, and better set of the observations. So fish sim performs more consistently in detecting phishing attacks compared to past work. The farthest point fast algorithm that we developed, this provides a systematic way for learning prototypes, and this does not require the data to be represented in a fixed vector or data structure. Okay, and our proposed method will still be able to continuously identify these attacks without the reliance on a specific feature set if we maintain up-to-date phishing data. And we use a data set called PhishTank as our data set for getting up this phishing website. So there are some limitations of the second approach, phishing. So there is something known as the zero-day attack in phishing, where so suppose some phishing website has come new on the market, you can say, I mean new in the internet, and it has not copied some of the existing phishing website or used a toolkit. It is completely new. So and if there is no similarity to the existing website, So you can see that there will not be any prototype which it is similar. So phishing may not be able to detect some of these zero-day attacks or new variants, because it is primarily focused on detecting variations of known attacks. And also, our proposed method can be improved by designing methods to effectively maintain useful prototypes, as well as by removing instances which are no longer relevant. So we did not have the prototype to be fixed. It can be dynamic. We can add new prototypes as new websites are coming, and we can also remove prototypes when those are no longer useful. So we can make it dynamic instead of static, and that will make the phishing detection much better. So here are some futures what we are doing. So we are trying different kind of compression algorithms, not just deflate. We are also trying different kind of distance functions, not only just the normalized compression distance. We are trying to see if a different prototype extraction algorithm can help. We are using automated machine learning to figure out whether these AutoML algorithms can beat our handcrafted machine learning algorithm. There is a lot of interesting work on computer vision based method, and we are seeing whether we can apply this computer vision based method to detect phishing websites. And finally, we are trying to use neural networks and particularly deep learning based method to detect phishing websites. So I would like to acknowledge my academic collaborators from University of New South Wales, Sydney, Ms. Richka Purwanto, who is our PhD student, Professor Sanjay Jha, and Professor Alan Blair. So they have been very helpful in stimulating academic discussion and ideas, and of course writing up the papers and giving comments on the papers. So this is a picture of the famous Hungarian mathematician Paul Edos, who is holding what is known as the book, where he thinks that God himself writes the most beautiful proof of all mathematical theorems in this particular book, and he is very fond of that. So with that, I would like to conclude my talk, and if you have any questions, please feel free to ask me. Thank you.
Enriching view. Request Dr. Balram Tyagi sir to kindly felicitate Dr. Arindam Pal with a memento and a certificate of appreciation. Thank you, sir and ma'am.
Moving forward, I would now like speaker Ravinder Singh. Mr. Singh is a alumnus, a technologist, rescue pilot, deep tech investor, and a global speaker with several hundred global recognitions and patents. His body of work, mostly first in the world, is making difference within acute constraints of culture and cash via commodity technology. He has been acknowledged as world's top 10 robotics designer, first artificial intelligence leader in Asia, and world's top 25 CIO. He has also been active around the globe through advisory, co-creation, hackathons, and innovation funding to create mass entrepreneurship at grassroots levels. Over a decade as an investor, he has mentored and managed successes and failures with a net portfolio gain of 22 times ROI. He continues to serve various international agencies during emergencies. His impactful body of work in the area of robotics, blockchain, AI, adaptive manufacturing, and cognitive computing has unlocked values across 5 continents by helping governments towards fiscal prudence and citizen services. Sir, it's an honor to have you here among us today. I would now request you to please address the audience. Please, sir.
You guys can hear.
Yes, sir, you're audible.
Okay, cool. Look, thanks for that introduction. I'm just an engineer who builds things, and sometimes I fly aircrafts. And nowadays, I work with remarkable entrepreneurs. Hopefully, all of you will open some kind of a startup which will become a large institution, and I help them to unlock value, because we are going through a state of a particular state in a civilization where disruption is bound to happen. And there are three reasons for that. And if any one of you have questions, just ask me questions. I just love when people ask questions. Look at business world today, traditional industrial world are happy. Companies are unhappy. Regulators are unhappy. And I can take a lot of examples for different domains. If you actually take an example of aviation, airports or airlines, not making money, they showed small. They're not happy. Today's era, so if you're really looking for a job, you're looking for a job in with a remarkable fresh, and I'll come to the topic, which is big data, industrial 4. Are no bank. It is Bitcoin. It fundamentally runs on a nodal infrastructure of one of the use cases which came out of that is big data. Big data is otherwise just a word. If you look at largest taxi companies, yes, it is Uber. It doesn't own any car. If you actually look at Facebook today, which doesn't create any content. If you look at the most valued retailer, it is any inventory. And I can go on and on, and since I live my life on hotels, the largest accommodation provider actually doesn't own any real estate, no guests over there. um, appearing, and this flywheel is a very, very simple, straightforward flywheel that innovation, new economies, and these new economies are creating new um, progression, and that industrial progression, few people certain of industry, different academia, they basically name it in a different way. Industrial 4 is just a word. So, so let's everyone talks about various five economies which are emerging, and they are cannibalizing existing industrial economies. And economies are, first one, create economy. And in a democracy like India, should have roughly about $30 billion a year, and it's just about 8 months old in US GDP. Okay, there are companies like Substack disrupting, where every creator is unlocking wealth for themselves and for everyone who is consuming that. Just one example. The second economy is which is creating ripples across the globe, and today is 1% of India's GDP. Not many people acknowledge that, is a platform economy. Okay, as I mentioned, there are companies like Alibaba Network and all that stuff, which are remarkably, and there's so many unicorns already being created in India, and use these two tech platforms. The third one I think will become huge in a country like India is an experience economy. Economy is about 11% of the European Union's GDP. So think about that. For this gig economy, which I think India will lead, today it is just about 1.5% of India's GDP. But if you actually look at certain, especially the central part of India, that will emerge as a nucleus of gig economy, while Uber and Ola how to monetize and how to unlock in these economies. That's the starting point. And the last very nascent stage, the circular economy, where systems will become hardcore of business unit, whether they are manufacturing aircraft, they are manufacturing retailers or a kirana business, and kind of circular economy will be born. It's not that big, but it's going to be a by 2030, at least in Europe, based upon the research which I have done. The point is that these existing economies basically run on fundamental principles of data structures and machine learning, and intelligence and restoration and texture of which you can get data, and you can name it whatever you want to name, but that's what is happening. Time on, I can address that to any depth. Since I'm a pilot and a reasonably good pilot, if you actually look at an aircraft, most aircrafts or a Dreamliner, they are e-enabled. Aircraft, when it takes petabytes of data, just one tick off. Consumers. Less than 0.6% of that particular data is actually a meaningful data. And that's the area, and where each of you I've invested in a company which is trying to create, and this is an example of circular economy, which is trying to create an alternate to induction motor. That means anything which is in motion, right from, let's say, aircraft to a satellite. That they want to make free motors, because rare earth free percent of rare earth philosophy. Another company which where I've invested, which is a robotics company, which actually use robots to reduce cost of by using robots. These robots exactly know where to pick up. The company which is trying to income of the last them rupees EV vehicles which can amplify their per day income at least 8. I'm just giving you some of the examples which are happening in India, not everywhere. They're all these economies. These 5 economies are going to become a dominant economies. Now, question this particular civilization for a very, very long time. No. And the cycle of economics, the cycle of GDP value creation will tremendously reduce. We don't have to wait for 150 years for one kind of industrial sector to dominate over other industrial sector or certain industrial sector. And that's the beauty of today's civilization, and that's the beauty of tech-driven businesses or sectors. Just to close my note, I'll just give you a few clues. Based upon my research and investment thesis, 5 different economies are going to emerge. They are at a very, very nascent stage. One is going to be space economy, which is going to be at least $1 trillion economy by 2050. So anyone who is a space engineer or who have an interest in space, they should explore that. This year I have invested in space companies which situational awareness, again, a hardcore data problem. Companies which are actually trying to solve problems in space. The second one, which everyone talks about, but nobody knows how it will emerge, is economy. This will typically only in 2 areas. The rest of the things will totally be disrupted by existing economies and other economies, I'm going to say. And the third one is electronic economy. It will be in India by 2023, in another couple of years' time. There are 2 other economies which are controversial in nature. Whenever I talk to various people, it triggers a decentralized economy. financial institutions, including institutions like companies, remain as they are, typically with a central framework of regulation, architecture, and systems. So financial services and asset management companies will totally be disrupted and will no longer exist in the next 15 to 20 years, and they will all be decentralized and they will run. And the last one is economy. About 1% of India's GDP today, but two industries, which is food and fuel industry, will be disrupted. All these industries will be driven or will have core big data, sensors specific to industry, and data latency edges driving them to monetize their business and generate revenues. What I'm trying to say is, while we do a lot of discussions on tech, algorithms, one of the things which I would like you to at least think and introspect is any algorithm today which you or your peer or your friend or any one of your acquaintance can write has a potential of not only creating a company, but may trigger disrupting a sector or creating an economy. That's the trend which is going to become aggressive. So talk should be not in terms of what technology is, but how to apply this particular technology to create new economies. And I would encourage all of you guys those lines and unlock a lot of wealth for yourself and for the country and for the civilization as well. If there are any questions, I can take those questions. If not, that's what we want to communicate. Thanks for having me.
Thank you, sir, for sharing your valuable views with us. It was truly enlightening. Now, I would request the moderator, Ms. Diksha Bhardwaj, PGDM first year student, to kindly moderate the question and answer session.
Good morning, sir. Sir, I would like to ask you that there was this report by PwC, and according to them, by 2030, 30% of the job will be automated. So do you think that AI will take over humans? And do you think, is it a myth that human jobs will not exist after 30 to 40 years, or we can overcome this?
Okay, let me give you 4 parts of this answer. One is a philosophical one. Look, history is always based on facts. If you read true history, and every time a disruption has happened, it has unlocked more employment. Okay, whether the creation of a coal-based engine to an induction motor, it has actually created more jobs while it has decommissioned existing jobs. Okay, so whatever the report says, the discussion and point of view of people who create policies in government or who run institutions should not be about the destruction or decommissioning of jobs. The discussion should be on reskilling. That's point number 1. Point number 2, AI versus singularity. I don't participate in that particular debate because I'm an engineer. I'm a very, very passionate engineer. I'm a practicing engineer. AI fundamentally has got many different views and viewpoints. But fact of the matter is, at a very, very simple level, it has got only 2 parts. One is a machine learning, and other is deep learning. Okay, deep learning accuracy still lies in most applied algorithms in the realms of 30 to 40%. I don't think it is going to drive decisions as of now in most sectors. In some sectors, specifically in cancer prediction and all that stuff, I've seen going up to an accuracy which is better than human accuracy. But in other sectors, I don't see them playing a much important role in decision making. Machine learning is already part and parcel, whether you are talking about digital twins in a hardcore industrial manufacturing sector, or you're basically talking about solving an optimization problem or a capacity problem. Part. The third part, wherever I have invested in companies, machine learning is basically a staple commodity now. Okay. So has it created more jobs? It has actually created more jobs. Today, if you actually look at, availability or the supply and demand, gap between in terms of talent available for a data from people who are data scientists to anyone who can tremendous. There's huge. It has actually created more jobs than we can actually. Is which you have hinted, what will happen in future? Okay, look. Today, okay, we have problems pertaining to people. To vaccination today's most vaccines are basically based upon algorithms, which has got very strong machine learning. On the other hand, we are solving the problem of climate. So how do you actually know who is contributing more? Again, connecting sensors to a machine learning code is becoming more and more relevant. The point which I'm trying to make is you may see artificial intelligence from a perspective of software. The real beauty of artificial intelligence, and especially machine learning, will happen when the convergence of edge and the central compute will prosper with the continuum of cost of compute going down. So job particular tremendous to create hopefully a better
and sir. Moving forward, we would now like to unveil the magazine Sericulture by Celebrate, the Strategy and Consulting Club of now request Dr. Convener, Dr. Khushbu Raina, Faculty Coordinator Celebrate, and Dr. Vikas Rai Bhatnagar, General Professor, and the editorial board of the magazine to come up on the stage to unveil the magazine. Celebrate is pleased to launch the second edition of Sericulture. The last year has been a roller coaster ride with the COVID pandemic hitting the world, challenging businesses to strategic and to adopt the new normal. This year's edition introduces an extensive range of fresh case studies, articles, and detailed analysis about the strategies adopted by various MNCs and the next generation CXOs. The editorial board extends its heartfelt gratitude to the members for their meritorious and sincere efforts in articulating the vision of the club. Through this medium, they also wish to extend their heartfelt gratitude to Director Professor Praveen Gupta Sir for his constant guidance, encouragement and mentoring. Thank you everyone. We shall now proceed.
Moving forward, I would like to introduce our next speaker, Dr. Rippon K Chakravarti. Dr. Chakrabortty is the Deputy Director of Capability Systems Center and the team leader of Decision Support and Analytics Research Group at the School of Engineering and Information Technology, University of New South Wales, Australia. He serves as the Program Coordinator of Master of Decision Analytics and Master of Engineering in University of New South Wales, Canberra. He has written over 145 technical journal and conference papers. His research interest covers a wide range of topics in operations research, project management, supply chain management, artificial intelligence, and information systems management. Many organizations have funded his research programs such as the Department of Defense, Commonwealth Government, Australia. Sir, it's an honor to have you amongst us today. I would now request you to kindly address the audience. We will be having a short break of 10 minutes. I request you all to kindly reassemble in the Audi.
I request everyone to kindly be seated. post this break, we'll be taking attendance also. Kindly be here, maintain the discipline. You all are requested not to use the cell phones. Keep your cell phones in silent mode. Thank you.
We will be starting in another minute. I request you all to kindly settle down. Moving forward, I would like to introduce our next speaker, Dr. Rippon K Chakravarti. Dr. Chakrabortty is the Deputy Director of Capability Systems Center and the Team Leader of Decision Support and Analytics Research Group at the School of Engineering and Information Technology, University of New South Wales, Australia. He serves as the Program Coordinator for Master of Decision Analytics and Master of Engineering in University of New South Wales, Australia. He has written over 145 technical journal and conference papers. His research interest covers a wide range of topics in operations research, project management, supply chain management, artificial intelligence, and information systems management. Many organizations have funded his research programs such as the Department of Defense, Commonwealth Government, Australia. Sir, it's an honor to have you amongst us today. I would request you to kindly address the audience.
Good morning, everyone. From my side, it's good afternoon. Just can give me a second. I need to share my screen, but before that, someone audible. You can hear me.
Yes, sir, you're audible.
Thank you. Just let me share if that is okay. Okay. Thank you. Thanks for giving me the opportunity, the platform to talk about my research and my research team. So thank you for introducing myself. So as you have heard, my name is Rippon Kumar Chakravarti, represent Kumar here. So what I'm going to discuss today is about artificial intelligence based extensions, how that can trigger the development of supply chain risk analytics. A quick like introduction about me is, of course, as you have heard, research group here in UNSW Canberra is about decision making and analytics. Like what we have been working on is mostly on the data driven decision making techniques and artificial intelligence, and we are applying different concepts mostly coming from AI to many business related problems and engineering problems. So when I'm saying business problems, somehow supply chain management and project management and all these things are within our scope. So the next few minutes that I'm going to cover today is about like supply chain risk management. This is one of our key scope or research area, and how artificial intelligence techniques can like help to identify or predict supply chain risk or supply chain operational risk, and then also management. So please, due to the time shortage, I may not have a detailed discussion on the technical aspects, but feel free to email me or contact me in any form, and I would be happy to talk through if you have any interest on the topic or any technical terms. Of course, as per the theme of this seminar, it is all about Industry 4.0, and we have, of course, I assume that all the audience here, they know about Industry 4.0 and supply chain maybe better than me. So here, as you can see, the tick on the smart supply network is, of course, one of the pillar in Industry 4.0 concept, and that's why here my discussion is more about smart supply network. So, and we all understand when I'm saying smart, that represents the digitalized supply network, and our discussion today is more about only this part and how that can, like AI can accelerate or help. But before I go to our research area, uh, here's some just quick keywords like the motivation, why we should work, or why there is a progression, or like the increasing trend of research, particularly on supply chain and project management domain. We all know that the aftermath of COVID-19 has affected the global supply chain significantly, right? Take border closure, lockdown, social distancing as examples. So there are many more examples that affect the whole supply chain, not only a localized supply chain, but also global supply chain. So that definitely, somehow shifted the traditional way of doing research. And then the emergence of artificial intelligence, we can't deny the merit of artificial intelligence and the extensions, how AI and its capabilities can help in making prompt decision in business related problems, including supply chain problems. And of course, the mass modularization, customer demand, and all sorts of things. I can keep talking about like a lot of all these things, the motivation about, like why we need to change the way we have been practicing in this kind of domain in supply chain or related areas. So, and that's why we said they are redefined challenges, because they are new. And of course, manager, someone who is related to the business, has to think about how they can better adopt this problem. And one thing is clear, that if your decision is incomplete, if your problem scoping is not accurate, whatever the decision you're going to make, in optimization language we will say that is not optimal. So this is another quick cloud of post-pandemic supply chain, as you can see here. So these are just different parameters. Say international politics in Australia. Because I'm in Australia, I know how international politics can also, somehow instigate and affect the global supply chain. Take up the current relationship between Australia and China. So definitely there has been many changes in the way the supply chain was maybe 2 or 3 years before in Australia. Then the climate change, the lockdown, increasing attention towards sustainability everywhere in the world. I don't think Australia is an exception, that we think about green supply chain and all sorts of things. So if I consider all these things together, that they will somehow affect the decision making, then you can see that every tier of supply chains or networks, they are vulnerable, right? There might be many cases the traditional process will be disrupted, or there will be uncertainties. So clearly we can see that if the traditional forecasting technique, traditional optimization technique may not help to solve all these things, and that's why we need advanced techniques. When I'm saying advanced technique, of course, before going further to talk about technical rigor, I need to tell about how I am thinking supply chain risk and supply chain risk management. I know many of you may have heard about this term, so I don't want to bore you talking about the definition, the bookish definition, but you can just skim through that. When I'm saying supply chain risk management, my discussion today is more about supply chain risk identification, the identification of supply chain risk. But definitely when I'm saying supply chain risk management, that comes with many other things, which is not within the scope of my presentation today. But we can understand that if your identification process is fantastic, if it is a good one, definitely management is much more easier, because all you have to do is to react based on the identified risks. So my topic will be more about how AI can use to identify or predict risks. So now when we say industry 4.0 and all sorts of things, definitely there are few fancy words came into our mind, which is IoT, cyber physical system, and all sorts of things. So you can see this is just a quick example, of course, taken from a reference, that IoT enabled supply chain risk management, how that should look like. These are new research directions, and like 2-3 years before, possibly nobody had thought about that, like how everything can, like how we can create a digital twin and start applying those start extracting the benefit of IoT and cyber physical system, even in typical business related problems. Okay, so I'm not going to talk about all the things, all the elements here in the picture, but you can see here that there is a way to bring a supply chain risk management within an IoT or cyber physical system framework, even as I have mentioned about the digital twin. So if, for example, if we can bring or if you can create a digital twin environment, just imagine that you are the user, you have a mobile phone on your pocket, and if something is happening, say you are the manufacturer, production plan, maybe a production manager, for example, okay, and you run a manufacturing house, and then all on a sudden, in your mobile, you got a notification that something is going on. So how you will get the notification is solely the benefit of digital twin or cyber physical system. So how that going to happen? Possibly you might have different sensors and many other things, and then it will come into a particular black box, which we say. So the black box, the way I'm defining the black box here is simulation plus optimization modeling tool. And possibly this is where I am different, like we are different. We means those who are working in optimization area also, because traditionally this black box is sometimes can be just a simulation software. Sometimes it is just a model, you know, but our intention has been mostly, okay, how about bringing simulation there, how about bringing optimization techniques there, prescriptive analytics there, how we can apply data analytics there, and of course the artificial intelligence and all these things. So you can think that my research group is mostly focused on this black box. At the lower end of my presentation, I will also talk, I'll challenge the black box, and I will tell you what are the cons and pros of black box too. So this is another new look or new way of thinking supply chain risk data-driven approach. Again, you can see here the optimization, simulation, and data analytics, how three important and powerful can coagulate together to manage the supply chain risk. Okay, so again, this is not definitely my contribution here, because I have taken from it references, but these are important to explain my research area. And the final one is our pathway. In my research, the pathway here is applying Industry 4.0, big data analytics, and Internet of Things. So these three, and of course blockchain. I have one researcher who is solely working on blockchain techniques in supply chain management. So these are the four important areas our research group is working on, and my discussion is more about when I'm saying AI based extensions, I'm somehow touching on all these four important pillars. So statistically, one important onus on us to understand how, like, if I see the pie chart, okay, based on a survey by one of my PhD students in this year, early March 2021, she found out that almost 40% research on identifying supply chain or within the supply chain risk management or supply chain operation risk management is evolutionary computing. 40% work based on evolutionary computing. I don't know how many of you heard about evolutionary computing. This is more about, say, for example, genetic algorithm, differential evolution, and all sorts of things. 35% are machine learning. So clearly it says that a lot of work in this area, and people still try to somehow augment the traditional machine learning technique to better facilitate the risk identification and all sorts of things. And only 1% is on computational creativity, 14% facility. So the main reason to bring this pie chart is to let you know that, of course, this is not an exception, that we can apply AI in supply chain problems. So how the next question will be how we can apply different deep learning approaches to predict supply chain risk. So before we start doing that, the methodologically, we somehow segmented different layers. Say, for example, data pre-processing, and then the intermediate layer when we use different deep neural network or convolutional neural network somehow to extract the features, and finally different classifiers to predict or to understand if there is any anomaly, or if the data what we are trying to predict is correct or not. So let me just give one more example here. So what we have done in this particular work is we collect some customer order data from online database. So for example, we use Kaggle database here. And then we used a pre-processing step. In the pre-processing, I know everybody understand the main benefit of pre-processing. Say, for example, if you have data from, let's imagine it comes with date, it comes with text, it comes with sentence, it comes with the different floating values and all other things. So definitely there should have some process so that you can normalize them. You can, pre-process them so that your machine learning can understand clearly. So after pre-processing, we use, as I say, different deep learning techniques, more than one always, to extract the feature. Once we extract the feature, it passes into classifiers. And again, we usually use more than 4 or 5 classifiers only to understand, okay, which classifier will give me the better result, because most often, it's very difficult to predict the the performance of a machine learning or deep learning model, because it is highly stochastic and most often it depends on the data. We all know. And if we use different performance metrics to understand, okay, which particular model will give me the best result or not. So here, what we have done, based on the data, we try to understand, okay, let's imagine I have millions of data. Out of that millions of data, there were a few, say, for example, it came late, okay? And maybe 99 or 95% order, as because they are customer order, came within time. So now I need machine learning technique to predict if my machine learning technique can clearly or correctly predict those 5% or 6% late orders. The benefit of that is, if my machine learning model can predict when what are the late orders, it can trigger me, it can let me know, okay, these are the cases when you will have late orders, based on the previous data. So now our target was to identify or to develop or to generate different AI models or techniques to see if they can clearly predict late orders or not. This is about pre-processing. I think I have already talked about that. And as I have said, we use different deep learning models while we did the feature extraction. Out of that, we use BiLSTM network. Feel free to ask me any question after the session ends, but definitely, as I said, we can talk about this later off the line too. So when we used BiLSTM network here, we all know the benefit of LSTM and BiLSTM, right? Because traditionally, BiLSTM has already proved better than LSTM if your data is sequential type. Of course, we use sequence type data, time series data, what I'm trying to say. And then the fully connected layers, I know that everybody understand what I'm saying. Fully connected layer. Fully connected layers is say, for example, one layer in the neural network so that it connects with all the all the activation nodes in another layer. It is good to the more connection you can create, the better your machine learning model can predict or understand. And then we use softmax layer. Again, softmax layer, we understand that it is more about somehow understand the unstructured data and come up with some probabilities values. And finally, in the classification layer, you can see it can classify what are my late orders and on-time orders. So this is just a quick schematic view of one of our deep learning model here. As I said, we have applied multiple deep learning models. Another one is here, say, for example, how about not BiLSTM, rather deep BiLSTM network? So because there might be many unstructured data, and we all understand having a deep BiLSTM network will give you better performance if you have multiple or many unstructured data. And that's why how we implemented the deep BiLSTM network, we just implement the BiLSTM network into multiple, you can see we have applied the BiLSTM multiple times here and there, first BiLSTM and second BiLSTM, and within that we have used different dropouts. So usually we do dropout to, to avoid from overfitting, sorry. And then you can see the other part is almost similar, our BiLSTM network, but here when we say deep BiLSTM, only these two and these two are different. Okay, I'll tell you how the performance were at the end. And the third deep learning model we used for feature extraction was one-dimensional convolutional neural network. Probably many of you heard about that. It came in late maybe 2020, but already proved as a fantastic deep learning model. And of course, it is a convolutional neural network, so all understand the benefit of CNN. And when you have one dimensional, you can easily make it in a vector, so that the whole identification technique is faster. So this is again another one dimensional technique. So if I just try to explain the results we have got after using 3 different deep learning methods, and of course, as I said, 6 different classifiers. Here you can see for some cases we have obtained almost 100% accuracy, mostly when we applied, like if it was a, say, one dimensional CNN plus support vector machine. In that case, most often we got 100% accuracy, like accuracy of identifying the late orders. And here you can see also that for one dimensional convolutional method, which is our proposed deep learning model, all of them are proposed, but these two are somehow modified. This is what we claimed, that our contribution, we had significant contribution there. And out of different classifiers, we saw that for SVM, we got 100% accuracy, which is undoubtedly a good achievement here. So similar thing motivates us to do further research. And of course, we are also working on many other projects somehow tangentially related to this one. Say, for example, here later I thought, okay, how about applying almost the similar methodology to, like to understand, say, okay, after the COVID-19 hit, how about if there is some anomalies or disruptions or unexpected behavior in my data? In that case, should my machine learning model will still, or deep learning model will still understand those ones or not? So with that motivation, we applied almost the similar methodology here. I'm not going to detail all this thing, but what you can see here, although I said almost the same methodology, but here we have applied different deep learning models and sometimes different set of classifier too. And of course, if you are looking at this clearly, of course, say for example, here the BiLSTM network, the whole architecture is not exactly the same here, but what we have got from our second experiment, when we had anomalies in the data, it is more about COVID-19 impact, like COVID information, the business data taken once, maybe sometime in 2021, but you can understand that it was somehow biased, not biased, crooked. So there you can see also one of our proposed deep learning model was, I think I didn't add that one here, did I? No. So for one of our deep learning models, we got 100% accuracy too. So summary here is, if your deep learning model is, if you can develop a good deep learning model with better application of classifiers, you can easily obtain 100% accuracy in predicting future data, which is somehow can easily relate to predicting supply chain risk. That's what I start talking about. Now, all my discussion so far is about black box, right? Because I have been talking about different machine learning and deep learning methods. But one problem with black box is that they don't explain what is going on inside the black box, and that is why they are black box. Many of you have already heard about glass box, which is explainable artificial intelligence, and very few, there hasn't been any work really on applying automated or explainable artificial intelligence in supply chain domain or in project management domain. There has been a few works in autonomous systems, robotics, trusted autonomy, but there hasn't any in supply chain management when I'm talking in 2021 November, right? Sorry, December. I didn't find any work on automated explainable artificial intelligence in supply chain management. So we all understand the benefit of explainable AI is, as I said, they are glass box, so they can explain why any particular anomaly is observed. They can also explain the interdependencies among different features. And they can also somehow explain the factors, the external factor which might impact the risk event or so. So these are some important benefit of having explainable AI. And like I have pointed out a few benefit of explainable AI in the supply chain risk management, but having said that, we have already implemented, last month we completed that work. We have already implemented the automated explainable AI to predict supply chain risk. But in that work, when I said supply chain risk, we thought, okay, let's somehow squeeze the scope, and we tried to understand how about if we apply automated explainable artificial intelligence to predict machine failure and all sorts of things. And trust me, it was a fantastic piece of work. So we saw decisions, you know. Techniques available benefit of black box and glass box. Summary here, black box is deep learning, machine learning, and glass box I'm representing is the automated XI. Unfortunately, the image quality is not that good because I tried to fit into the computer problem. Exactly is there are 5 different modules, and each of these modules are somehow related to deep learning models I have explained. And at the end, the benefit is it will explain to me the impacts and also the relationship among different features. This is the slide which I was requested to put by Mathematics Journal because I am an associate editor there. And if you have any interest publishing any papers in that one, of course, that is a Q1 journal. Feel free to submit any papers there. And thank you. Thanks for your patience hearing. I hope I am on time. Apology if I was a bit rushed, but I'm happy to hear any questions if you have. Thank you.
Mitigate as recently in April 2021, Prof reported that they had a supply chain attack which remained undetected for over 2 months. So what are your views on that?
Thank you. Thank you. It's a very, very good and practical question and relevant question. Definitely, my discussion wasn't really about identifying supply chain attacks. Fortunately, one of my students, she has been one of my students was working on this area. So it is another very important area, you know. Unfortunately, I'm not the expert to talk about that really because I haven't really stepped my foot into identifying the security stuff, you know, in the supply chain problem. So I don't want to give a false hope. Apology for that one because that is definitely not my research area.
Good afternoon, sir. I would like to ask that how much time and what organizational changes will be required by the Indian companies to deploy these models?
It is very simple. Thank you for asking this question. So our plan is now, we have already contacted one company in Australia and they showed their interest. So, you know, the tool we have, like there are multiple tools and kind of a decision support systems we have created. So we will hand over this to an industry and, you know, all they need to do is just give their input and it will automatically tell the output. So it is very easy and straightforward. It shouldn't take time.
Thank you, sir, for answering all the questions. Thank you, Diksha. I would now request Dr. Rajkumari Mittal and Dr. Balram Tyagi to kindly felicitate Mr. Chakraborty with the memento and certificate of appreciation. Oh, I'm so sorry. Actually, Dr. Rajkumari Mittal ma'am wants to ask a question, sir.
Sure, please.
Good afternoon, sir. My question is resilience as a concept across supply chain is, I mean, we can find it on paper or in policies or in, the organizational objectives or long-term strategies. But how can we introduce it across all supply chains through digitization or the AI modes and any other suitable mode? It's very tough, especially to find it across service industry.
You nailed it, ma'am. Exactly, you're right. So it is not as it heard, because when you say resiliency in supply chain management, people from computer science background, they will try to understand, okay, if the resiliency is within the supply chain networks or not. If someone from industrial engineering background, they will understand resiliency is more about robustness and handling uncertainties. The way we define resiliency is different from perspective also. And even if you ask someone, let's imagine completely biased with artificial intelligence, in that case maybe he will define resiliency as if that his methodology will still work if you change something. But to me, from a background, like I do have background on industrial engineering plus computer science, so how I define resiliency is more about like how we can come up with better strategies across different supply chain tiers or parties or echelons, so that the overall supply chain profitability can be increased, even though there will be anomalies, there will be disruptions, there will be some uncertainties. And now what I have just said, if you want to minimize or maximize, say for example, maximize the supply chain profit with providing that much buffer to deal with those uncertainties, you have to work into different ease of networks. So I don't know, many of you have heard about bull effect, you have heard about ripple, like a kind of a consequence of not following resiliency in a supply chain network. So these are very important terms, and definitely we should apply, we should start think about resiliency in this post-pandemic era more than what we used to deal with. And if you see, surprisingly, I shouldn't say surprisingly, expectedly, in last few months, if you just simply Google it, you'll find a lot of recent works on resiliency and disruptions in the global supply chain domain, particularly once the pandemic hits, because the whole research direction is shifted now. So it's a fantastic question, ma'am.
Thank you, sir. I would now request Dr. Rajkumari Mittal and Dr. Balram Tyagi to kindly felicitate Dr. Chakraborty with the memento and certificate of appreciation.
I wish I could be there.
Thank you, sir. Thank you, ma'am.
Now, I would like to introduce our next speaker for the day, Mr. Bohitesh Misra. Mr. Misra is the co-founder of Decision Tree Endeavor Private Limited, previously held the position of co-founder and CTO with fintech startup, and has more than 25 years of experience in managing mission-critical IT DevOps, digital transformation, planning and managing IT services, pre-sales, PMO, delivery, and improvements within various sectors. Mr. Misra has been a part of the team involved in development of Indian Railway Reservation System and has helped in IRCTC performance improvements. He has recently been awarded COVID Global Superhero CIO 2020, Smart Innovator Award, IT Next 100 CIO, Top Eminent CIOs of India 2018 and 19 by VAR India, and winner of Top CIO 200 Change Agent 2017, 18, and 19. Mr. Misra has also featured in the 7th and 8th brand book of ICT Industry 2018 and 19 as top industry IT leader. He is currently a member of Industry Academic Council of Abdul Kalam Technical University, Lucknow, Academic Council member at Institute of Management Technology, and mentor with Dr. Kalam Startup Parikrama and Innovation. Sir, it is an honor to have you with us today. I would now like to request you to please address the audience. Also, sir, I would like to mention that you have been given presentation rights, which would allow you to share your presentation. Please, sir.
Thank you. Thank you. Okay, so a brief, thank you for the brief introduction. My name is Bohitesh Misra. Details are provided. Mobile number and email ID is provided. I'm a BTech Computer Engineering and an MBA in Marketing and a Data Science Executive from IIT Delhi. 5 years of IT experience, I have developed one of the key members of the development of Indian Railway Reservation System, the kind of biggest system that you can think of. So, been part of the designing of AC 3-tier, which primarily changed the perspective of moving into ACs, and the cost of it came down. So the AC 3-tier design was primarily a computer integrated manufacturing at Rail Coach Factory Kapurthala. So we have integrated all the CNC machines, robots with the mainframe computer using fiber optic, and that was year 1991-92 time frame. So think about it, that all what we are talking about as Industry 4.0 actually started somewhere back in 90s, where all the CNC machines, robots, they were all connected to the mainframe computers, and all those CAD/CAM systems were able to communicate with the CNC machines. So that kind of an automation has already happened at that point of time. Okay, guys, so the session we are more focused into solar IoT, fintech, edutech. 4.0 concept was conceptualized. It would be is being the Industry 4.0, calling it as so as 4.0 to 5.0, it is more by the automated process. Success. One statement from McKinsey, it says that the early adopters of Industry 4.0 report stronger ability to respond to the COVID-19 crisis. It's a very powerful statement, I would say, saying that those industries who have already implemented or have a maturity level of Industry 4.0 were successful in this COVID-19 crisis. That means the automation level was high. People were able to remotely manage and monitor their systems. In such a case, the production was not so affected, and they came out very stronger in this crisis situation. Even Future Market Insights talks about that this smart factory is more than 215 billion by 2025. So it's growing, which was just 51 billion in 2014, say 5 times or that kind of a multiple growth it would see in next few years. Even it's a 10 to 15 trillion of global economy in next 20 years or something. So that's the kind of volume that or the potential it carries, Industry 4.0. So these are some of the modules of Industry 4.0. So be it advanced robotics, Internet of Things, right? And big data. So I'll be talking some of these modules in brief, in detail as well. Big data, augmented reality, or horizontal and vertical integration. So I'll talk about that in detail. Simulation, cloud, additive manufacturing, cyber security. It's a major concern with Industry 4.0. So with these modules, it is an integrated collaborative modules make it a Industry 4.0. So the core of Industry 4.0 is like combining the internet with manufacturing. And these are some of the modules of key modules of the Industry 4.0. One is cyber physical systems. These are all embedded systems as part of your lot of sensors and those embedded systems. The IoTs, which are these sensors sending the data to the central servers through communication channels. Digital twins, automation and robotics as key one of the key modules. Next comes the cloud computing, your analytical part, or the AI, and so these makes the major modules of the Industry 4.0. Additional components would be your 3D printers or the augmented reality and virtual reality and the simulation environment, right? So these could be some additional components of Industry 4.0. So it can be interpreted as the integration of automation and information. So when we talk about Industry 4.0, it is primarily these digital factories. So focus on digital factories is the key topic of Industry 4.0. So according to the Association of German Engineers, digital factory is primarily a comprehensive network of digital models, methods and tools, including the simulation in 3D virtual reality and visualization, which are integrated through continuous data management and with the goal of design, modeling, simulation, evaluate and optimize these products, processes and systems before any modification is actually carried out in these physical systems. So when we talk about the IoT, so these are all Internet of Things. I was doing a project way back in 2003 or 4 when we had a very small simulation, a sensor, pollution sensor, which we dipped into one of the rivers in Punjab. So the project was given by Punjab Pollution Control Board. So we used to dip those sensors 1 kilometer apart. And then because there was no connectivity and network available at that point of time, but there was memory in that sensor. So we would go and collect the data, pull out that sensor, connect to our laptops, right? And export that data into our laptop, right? So, and even the geolocations we would tag at that point of time. So but that was 2004-5 time frame when the with them, but sensors have become they are able to directly. Processing it, then send the relevant of information is going to grow. It is more than 1 trillion kind of a revenue it is going to generate in next 2025, right? So the complete you see a lot of sensor technologies and protocols. Technologies that they communicate with the central or other applications like CRMs, supply or ERPs or some dashboarding systems, right? So this is a complete data center view of from the sensors to the data, end applications. So challenges are many in IoT because IoTs are those, it doesn't have that much of a capability to have a lot of security inbuilt into the systems. So when you deploy a IoT, the challenge would be that the firmware it carries gets older and newer threats happen. So you cannot regularly update those firmwares. So that is one of the challenge, right? you would see that they get older, and the possibility of hacking those IoT devices is quite high. You would have seen recently Mirai botnet attack, which happened in some few years back. It was primarily from these IoT sensors, and those firmware were deployed, and all of a sudden they started projecting a lot of data to the central servers, and it choked the complete network. So complete internet was choked for almost 2 days because of that IoT attack. So when we talk about Industry 4.0, the big data, when we say, what are those applications, right? So it could be because of improving the warehouse processes, right? All these sensors and portable devices, they can improve the operational efficiency by detecting those errors in the systems. Second could be the elimination of bottlenecks. So big data identifies various variables that can affect the performance. So big data will identify those bottlenecks. Next is a predictive demand. So more accurate and meaningful predictions with visualization of activities through the internal analysis, which is your customer preference, and the external analysis, which is trends and external events, give you a very optimized product portfolio. Next could be predictive maintenance. So as these sensors give you a lot of information to the central servers, it can identify a possible failure in these systems. Talk about where India is with respect to Industry 4.0 implementation. So we see that those developed countries in the index of 1 to 10 are at a higher level, but India from the developing countries have moved to a newly industrialized countries wherein the maturity level has increased, and with COVID-19, so a lot of manufacturing industries have started automating their factories. So because of Make in India and other initiatives, so the level from developing countries have moved to a newly industrialized countries, and the level has enhanced. So these are some of the initiatives from various countries. You can go through them. I'll be sharing this presentation with you all. So for India, it is all Make in India, and different countries when they actually started Industry 4.0 initiatives. So we see that embedded is everywhere, right? So be it at your home, right? Even your fridge contains a smart RFID tags, and it can order your grocery as it checks your content in the refrigerator, and accordingly, if your payment gateway or credit card is connected to that, it can order those groceries as well. The smart homes, smart workplaces now, right? Voice over IP phones, right? HVAC controls, which can control your temperature, and lighting systems. All your vending machines, it can also automatically reorder your supplies before it gets empty. So security systems in the building, right? Media players, you see embedded systems everywhere. So these sensors could be placed in your use cases. Any tsunami is happening. Get to know robots have penetrated. So what is common in these systems? So they have a computational core that interacts with the physical world, and which is what we call it as cyber physical systems. So cyber physical systems are very effectively used in your Industry 4.0. So these are engineered systems that require tight conjoining of and coordination between the computational and the physical. So trends of the future would be cyber physical systems will be smarter and more smarter, and more intelligence will be in the software of these cyber physical systems. So some of the examples of these sensing devices could be in automotive controllers, avionics, right, medical devices, industrial controls, infrastructure, transportation. So, and the computational would increase, but not the first and foremost is a computer integrated with the physical processes like sensors, actuators, and your physical dynamics. Reactive at, so it has to react at the speed of the environment, whatever is the environment accordingly. So these have to be faster, right? Almost on the real time, heterogeneous, different combination with of different type of systems can interact with each other, and they have to be networked. So what are these cyber physical systems? It's a system featuring a tight combination of your computing and the physical element. So these are the integration of IT systems with mechanical and electronic components connected to online network that allows the communication between machine and with the social networks. So CPS, which is cyber physical systems, they use computation and communication deeply embedded in and interacting with physical processes to add new capabilities to the physical systems. So they are not in isolation now. So they are all connected, and CPS or the embedded systems make it convenient for those systems to interact with the social world. So a lot of use cases are available in the aerospace, automotive industry, chemical production, civil infrastructure, energy, healthcare, manufacturing. So almost in all the domains now, the cyber physical systems, all these sensors and actuators, they are now able to communicate with the central servers, and even the device to device communication can happen, which is your digital twin and all that. So why do we need cyber physical systems? These are making it efficient with low emission, right? The emerging computing and communication with physical processes brings many benefits like safer and more efficient systems, reduce the cost of building and operating systems. And technological and economic drivers would be the decreasing cost of computation, networking, and sensing, providing the economic motivation. Computers and those communications enable the national or global scale CPSs like national power grid or national transport network. So which gives a social and economic force requires more efficient use of the national infrastructure. And it helps in reducing the pollution and health and bio. Similarly, critical infrastructures, they all use a lot of sensors so that they can effectively manage through the remote controls. So now we move on to some of the technical challenges of these the CPS or IoT or the cloud computing. How can we build intelligent and safe digital systems that interact with the physical? So that's one of the challenges. It has to be safe, and you have to keep increasing the intelligence. Beyond the current technology, the computing side, there are limitations in digitization for continuous world, and computing abstractions currently focus primarily on the functionality and secondarily on aspects of the physical world. From the engineering side, it is all intelligence that has to be as embedded as part of the softwares, and bridging the two, the physical and the software side, is again a challenge. Another challenge is the the vulnerabilities in the as we said that these IoTs and sensors, they have their firmware and a limited security feature, so they can be hacked very easily. So somewhere the vulnerability is a major challenge. So network controllers are those, so they are actually computers. However, their version gets depleted and they are older, and accordingly hackers try to hack into those systems which have those vulnerabilities available. So commodity IT solutions, new functionality, smart infrastructure, many devices have those vulnerabilities available. So which leads to these cyber crimes. So some of the examples of vulnerabilities which were exploited last few years was the oil platforms, the sewage control system, right? Some canals were controlled by these hackers, and national grid. We saw some of these use cases where national grid was controlled and it was shut down because of these hackers. And one of the case wherein hackers have attacked the utility systems and they were able to control the devices. So it is scary. However, a lot of potential is there to optimize these vulnerabilities. So these attacks are primarily on the integrity part and the availability part. So integrity would mean that the data is being compromised. Trustworthiness of these sensors, the data. So if the data being sent from these sensors, if it is manipulated, because you are believing on that data, and if that data is being, the integrity of that data is being hacked, right? So it is a major challenge. In this, you can see A1 and A3, the integrity is being attacked. The data, physical systems, the data is being changed and it is not giving a real picture. Similarly, on the availability. So all these, if the denial of services, right? All those attacks can be done to shut off the system, cut off the system from the mainframe or some cloud computing. So which will lead to a total chaos. So integrity is primarily those data manipulations, and availability is cutting off the system from the network. So when we talk about the industry 4.0, this smart factory is one of the key factor of the industry 4.0. So the applications of Internet of Things and services is one of the key part of the digital smart factory. Cyber physical systems, as I said. So these are all your CNC machines. There's a lot of sensors embedded in these, and those be it connectors, routers, all these IoT devices, they all contain those communication protocols and their embedded software, which makes it a cyber physical systems. So machinery related advances have happened in the machining of mass production, increased use of additive manufacturing, and safe human hardware. So the expected advance related to IT should enable the autonomous production, the self-organizing factories, digitalization of the entire end-to-end process, and integration of supplier and production network, and transition from big data to smart data. So big data concept has been implemented. Now it is time to move it to a smart data, wherein data analytics and machine learning techniques have been used. So these are some of the standard products that have been being used in the smart digital factories, be it CAD/CAM, CAE kind of a system, right? Which we have used in designing of AC3 tier. I'm talking about 1991-92 timeframe, where the complete simulation of the design was done on the CAD/CAM and CAE. We did a finite element analysis directly onto the system, and when we were satisfied and we could test at the speed of 150 kilometers per hour kind of, and then we moved it to production. So directly connecting mainframe computer to the CNC machines through fiber optic and other communication channels, and we could directly move it to production that way. And PLM, the product lifecycle management, so it has all the modeling, simulation, and visualization tools. Similarly, MES system, manufacturing execution systems, which includes the software control integration. Then you have the ERPs, right? The enterprise resource planning, which can be MRP2 for scheduling the job schedule and all that. Order processing to logistics to planning of the complete resources can be done on an ERP. And then you have the supply chain management, which is across the industry, and a CRM, which is interacting with your customers and vendors. Next comes the BPM part, which is your business process management. You need to optimize your business processes according to the usage of these the different CAD/CAM, MES, ERP, supply chain, CRMs. Then you need to use the BPM solutions. In Industry 4.0 of tomorrow's, we need to have a vertical network and a horizontal network. What does that mean? A vertical network means that your business's processes of across the organization should be integrated, right? It should be a seamless integration across all the different factories and different enterprises in the organization. So this is vertical integration. Horizontal is across the industry. So one factory, so be it manufacturing industry or an automotive industry or some different kind of an industry. So integration across those is called the horizontally connected value networks. And they both enable and require end-to-end engineering across the entire value chain. So horizontal integration, as I said, it is across the industry. So one industry, the inter-industry value chain is the horizontal integration. Next is a vertical integration, which is across your different business processes. So you need to have the complete organization and different manufacturing industries seamless integrated into a single environment, which is all your vertical integration. So the future scenario of Industry 4.0 is your all these integrated processes. So somewhere you have to improve on your BPM tools, real-time data access to and from the shop floor levels, and a predictive maintenance methodology. So some of the challenges from Industry 4.0 is like, so we all know that the technology used would be quite high, and those qualified and experienced specialists are less not available. So somewhere we have to train them on the shop floor about the new technologies. So that's one of the challenges, gap in the technical skills. Next comes the data algorithms. When you have to start sharing that data, it is not, it is privacy and policy of that data. That we interoperability, so between one device to another is a challenge, and because every device has a different OEM and different protocol, and connecting with a different device altogether a different protocol is still a challenge. Security, as I said, because these cyber physical systems and your digital systems in the shop floor, they still do not have the latest versions of the security vulnerabilities. So people can attack through these IoTs and different CPS systems. Handling, another challenge is the handling of data growth. So the kind of data that is being generated from these connected devices and connected industries, it is tremendous and humongous. So it is still a challenge how to handle those big data now. So the point is that somewhere the AI algorithms will need to be able to combine the data that might be of different types and time frames, and will be only the summary of that would be used in taking a decision. Some other challenges are like high cost of scaling. So people or industries have already deployed certain CNC machines or robots or automation level. So how to scale up for Industry 4.0? So that's still a challenge. Lack of data analytic skills in house. Anyway, I talked about one which is particular for the Indian industry is that jugaad attitude from the plant floor to the management level. Chalta hai kind of, right? Do this way. Find an alternate solution to this problem. So that kind of a jugaad attitude is not making Industry 4.0 a success in the country. So lack of courage among investors or the management from an unclear ROI or value due to low transparency from the supplier side. So that's again one of the challenge. Lack of trust and fear of failure. So somewhere you have to take a lead and believe in the newer systems. That's the key to the success of Industry 4.0. And lack of interest in innovation, less support from the shop floor employees. So these are all these shop floor employees. They are very routinely engaged in their activities. They do not want to change their processes or learn something new. So there is still a challenge from the shop floor employees. Unclear budget values presented by the project head. Lack of leadership support from the top, right? And too many stakeholders for implementing us. So you need technology, your IT, or embedded hardware, electronics, mechanical. Everyone would be required to make Industry 4.0 a success. So a lot of good coordination between all these stakeholders is still a challenge. So when we talk about specifically from the MSMEs, so the challenge are a bit different. Lack of clear digital visions because they are mid-range, micro to mid-range enterprises. So they do not have a lot of money to be spent on automation. So that's still a challenge. Fostering a strong digital culture, that is a challenge specifically with the MSMEs. Data security, level of digitization, lack of data analytical. So most of them are similar to the ones which we discussed. However, in MSMEs, the proprietary standards are prevalent, right? So they have implemented one kind of a technology. How can they spend more money to just upgrade their systems to latest technologies or which are required for Industry 4.0? So that's still a challenge for the MSMEs. And I believe that a desperate need to adopt these trends are required. Applying industrial IoT to secure business continuity and enabled asset optimization. Remote employee collaboration. So anyway, COVID-19 has given a flexibility to understand the employee remotely managing those employees, and even so there's a need to implement Industry 4.0. So there's a pressure in the industry to implement Industry 4.0 quick and fast because that's the need of the hour. Digital performance management and inline process optimization. So these are some of the techniques that have to be implemented. Supply chain integration. So the previous speaker was talking about supply chain analytics, risks in that, right? So that is what supply chain integration across the value chain, that is key to the requirement of the industry now. Use of 5G and blockchain implementation has come up, and which will be effectively used in Industry 4.0 in coming years. Quantum computers primarily perform calculations based on the probability of the object state before it. So earlier we have no zeros and ones are there, but this also takes care of the probability of object state, which is it can potentially have a process of exponential more data compared to those classical zeros and ones. So quantum computing has many states in between. So it's kind of exponential states available which can be managed. So this is the trend. My suggestion to the industry is that we owe our future generation a better world, and COVID-19 has given India an immense opportunity to automate supply chain and use analytics in the supply chain management. Even the professor from Australia, he was talking about supply chain analytics, which is the need of the hour now, right? So supply chain has moved closer to the end users. So across the industry, if supply chain is there, so they are all consolidating towards the and an automated or a more analytical view on the supply chain is required. So need for free flow of available knowledge and instruments. So people need to get trained on these newer technologies, and cooperation between the industry, research institutes, and so people have been doing a lot of research in that. So that has to be taken to the industry. So this kind of these kind of sessions which we are doing today, and people coming from the industry, from the research academia, so they have to collaborate to confirm on their research knowledge into the industry. So for Industry 4.0, I would say these are three major steps. Create awareness of the importance of innovation. So creating an awareness within, so what are the benefits? You have to educate the innovation management team as well. So at the top level, they have to get educated and identify the potential improvement. So move step by step. So you don't try to implement everything so that it's a total chaos. Keep improving on the processes. So primarily, I would say that in manufacturing driven economy, digital factories are the key to the sustainability and competitiveness. A digital factory concept is hugely relevant for Industry 4.0 since digital transformation implies the transition from digital smart factory to smart production service kind of a system. So in order to accomplish the task, future research on information systems are needed to provide full integration and digitization of end-to-end processes. The challenge is end-to-end processes, understand that. Across the entire value chain, just not in isolation, the vertical and horizontal integration across the value chain, right? In a networked environment, so it's talking about the CPS system with the cloud and enhanced cyber security of the digital factories. So that was about my session on the cyber physical systems and the challenges it is there in the industry.
We won't be able to take up request Dr. Singh and Dr. Rajkumari Mittal to speak a memento and certificate of appreciation.
Thank you.
Thank you, sir. And thank you, ma'am.
Thank you so. Have a nice day. Thank you.
Thank you,
friends.
sir.
I would now like to introduce our next speaker, Mr. Abhishek Nag. Mr. Abhishek is an astute, innovative, and passionate entrepreneur and a thought leader. He is the CEO and founder of Embarking on Voyage, his brainchild and current passion. Mr. Abhishek nurtures strategic and long-term relationships with everyone he worked, adding a personal touch and energy to all his clients. Sales strategy across ISV, international organization and enterprises are some of the areas where Mr. Abhishek's thought leadership is widely revered. Mr. Nag has always led by example and he advocates the spirit of learning and polymorphic problem solving. His revolutionary approach to sales and organizational development has resulted in a solid pipeline and connects across geographies and across various industry verticals. Sir, it is an honor to have you here with us today. I welcome you to please share your valuable insights. Please, sir.
Very wonderful to everyone in this forum. I hope you all are doing good and staying safe. Just allow me a few minutes. I just need to make it a full screen, right? Yeah. So great. I am pretty much sure since morning you guys are going a lot of presentation. I have a very short number of slides with me. A quick background about me. I've been in the industry for almost like a decade and a half, worked with a dozen of Fortune 100 clients. My venture, my brainchild, EOV Digital, we started last year. And in a very short span, we grew from 3 people to about 40 people with a client of 26 clients running 47 projects with a plan to grow up to 110 to the end of this financial year. Let us quickly move on to the presentation where I'll be just talking about the digital innovation in Industry 4.0, where we are witnessing the fourth industrial revolution. Let us go with the journey, what Industry 4.0 and how it started, right? So it started from Series 1 to Series 4. So the Series 1 is actually the time when it started in 1760. It is the time, it was pre-independence era when we were, doing a lot of production, mass equipment production and steam power. The next, what happened was a revolution, which was translated into Industry 2.0, wherein we faced, this was a time in between 1760 and 1840, right? And this was a time when we were facing the challenges with electricity, mass production, and assembly line. In the mid-19th century and early 20th century, computers and automated production procedure was introduced, which eventually got over with Industry 4.0 from 2011. Let me ask you, what are the 5 fundamental digital foundation in Industry 4.0? Any clue? Before looking into my slides. Okay. These are the 5 basic fundamentals. Your cyber physical systems, your IoT, your big, small, and wide data, cloud computing, and cognitive computing. According to the research conducted by Gartner, all right, and also with some of the leading market research agencies, the global Industry 4.0 market size will be rising from $68 million from 2018 to about $205 million. That means we are expecting a CAGR of about 17%. To be precise, it's 17.06%. Quick question. What are the top 10 future technology trends in Industry 4.0? Let's go with the clockwise. Okay. The first is AI engineering. I see a lot of people talking of artificial intelligence, but trust me, in coming days, AI will be dead. Very surprising. Yes, AI will be certainly dead. It would be replaced by something called large data and void, VOID, distributed cloud computing and edge computing, privacy computation, 5G, intelligent business process and vendor platforms. Very new concept, Internet of Behaviors. We all have seen IoT, RPA and hyper automation, human-centered digital experience, remote and digital workspace technologies. A lot of companies, they have come out with their own set of platform in the hybrid model, right? To augment all their resources on one platform. Zero trust and cybersecurity. These are the 10 globally popular use case in IoT. The first popular use case is about the remote asset monitoring. It's all about a smart operation. Now, let me tell you, IoT, earlier it was in the mindset that it has only needs to be in the manufacturing segment, right? The concept has radically changed. Before the COVID, I was in the United States and I was witnessing one of these events, South by Southwest. And there I was talking to John Nerrell. He's the CIO of Johnson & Johnson. And I was saying, hey, you know what? Industry 4.0 is for the manufacturing. And my thought process absolutely changed after my 90 minutes of interaction with him. Industry 4.0 does not restrict to manufacturing or to shop floor. It is across an organization. You name any function where Industry 4.0 does not exist. Industry 4.0 is an industrial revolution through automation, hyper automation, optimization, application monitoring. Yes, certainly. I was just relating to the previous speaker. He just highlighted, Mr. Misra highlighted. I also see there are large number of challenges with Industry 4.0. The first is it's a gap in technical skill. There's a huge gap. What we expect, what we want to be delivered versus the kind of the skill set that we have. That's a huge gap. Primarily of the fact, we tend to see academic, industry, and laterals. They are on 3 different silos and platforms. That's one of the fundamental reasons of this gap. Second is the data sensitivity. Third is interoperability. Fourth is security. Fifth is handling data growth. So what you see data today, I remember up till a couple of years back, we used to have data in GBs. Now for the same client, we are handling data in TBs. Okay, who's ahead in Industry 4.0? So we have identified by region, we have identified in terms of the industry, and obviously in terms of the clientele. So if you see, North America has always charted, all right? GE, Boeing, Tesla is definitely there. If you look into this, I just wanted to give you an overview of who is doing in terms of the region. So I'm pretty much sure in a couple of months, you will all be going out chasing the market. You remain well prepared as to which country and for whom you need to approach with your Industry 4.0 knowledge. If you look at the chart, about 36% of the industries in North America are already on Industry 4.0, which means your focus and your knowledge should be more in tune to the international mechanism of industrial automation. Europeans are very process-driven, extremely process-centric. They're still in the phase. Being a German national, I have at least witnessed about 18 meetings, right from BMW to Audi to everyone. Audi is still in the early phase, whereas BMW has only initiated the process. About 9% of their entire industry automation is on Industry 4.0. Asia, oh man, China is always ahead of the league. In terms of the industry, who top the charts? If you see, it is typically Siemens and the chart first. From US, it is GE, and obviously from US, you have Boeing. In terms of the industry, whose lies ahead is obviously automotive. It is not only the production, but trust me, the procurement, the supply chain, the manufacturing, the sales, marketing, everything, every single aspect is being covered under Industry 4.0. The second state where it is extremely there ahead is the compressor, electronic and electrical industry. Third is the metal and mining. Fourth is process industries. These are usually the oil refineries, machinery and equipment, energy, Suzlon. They always come on the top, Suzlon. Discrete industries, these include a lot of high-tech or travel tech industry, and there are several hybrid industry, like the food processing industry. According to McKinsey in 2025, IoT, especially as a part of an Industry 4.0, the IoT application will be about $11 trillion impact business to the world. Yeah, this is an interesting slide for me always. If you remember, I said Industry 4.0 does not necessarily mean for manufacturing. It's beyond. It can be used for every industrial sense. Where can it be used? It can be used for synthetic reality. Any idea what synthetic reality is? Although the image clearly says it's a virtual reality, but any idea which part of the business does this addresses to? Lunch break, okay? I think all are silent. Hello, am I audible?
Yes, sir, you're audible.
Okay. Clue?
Sir, so sorry, we do not know about synthetic reality.
Synthetic reality, okay, how many of you are from South Delhi? Okay. Very recently, which are the top brands, international brands have you visited? Versace, Dolce & Gabbana? Okay. So synthetic reality supports very much widely about the sales side of the world. Let me give you an example. If you know, there's a camera called GoPro, right? Do you know how exactly GoPro used to be sold 3 years back? They used to be sold in a golden cage. Yes, in a golden cage. I was in the United States for the Falcon Malbridge Award to receive on behalf of my client called Beyond Curious. And there I saw very nice camera. I could able to see Sony, Nikon, Canon, Yashica, and any good brands you name, right? But GoPro, I was unable to do. Why? Because the camera used to be stored in a jewel box kind of concept. So what happened was the sales guys were in a negative sales report, right? Now what happened? Through technology, I used to carry my tab, and before the phone and before the camera, I used to play like as if I'm playing with a Canon. That's synthetic reality. Synthetic. It is not genuinely in your hand, but still you get the feeling of what the genuine is. Second is contactless. You go anywhere, you have contactless payment, right? So you just go, you tap your card and get away. It is still in the early stage. In India, the adoption of contactless is less than 20%. Third is the robot and drone-based delivery. I have not seen the drone-based delivery in India, but yes, I have witnessed this in Netherlands where I wanted to order something from Amazon, and it was delivered to my hotel room through a drone. That's a part of the future of delivery. Fourth is behavioral biometric. Oh, by the way, sorry, the font that I missed out is like synthetic reality is very much for the sales and the marketing. Contactless is very well managed for sales, operations, and finance. Robots and drone-based delivery. This supports the supply chain. This supports your logistics. Behavioral biometric, extremely important for the HR in any organization you pick up. Quantum computing. It relates to the IT. These are the few reference sites from which most of the data have been taken over. You already have Shubhangi's presentation. And with this, I thank you for your time. Open to your questions.
Thank you so much, sir, for sharing your valuable views with us. Now I would request the moderator, Ms. Yashika Narula, a PGDM first year student, to kindly ask questions on behalf of the students.
Good afternoon, sir. Thank you for the insights. So, can neurosensors be included in IoT to help bridge the gap between AI and human intelligence?
First paragraph. Can you repeat your question?
Yes. Can neurosensors be included in IoT to bridge the gap between human intelligence and artificial intelligence?
Okay, let me ask you a question. Today morning, first let's understand one basic thing. There's a fundamentally strong difference between a human intelligence and a robotly trained data-driven intelligence. Okay? If you ask me, practically it is tough. Fundamentally, being on the science side, yes, it is possible. Does that answer your question?
Yes, sir, it does. So we have another question for you. How is lean manufacturing different from the industry 4.0?
Good question. See, let's understand. Industry 4.0 is all about digitization, automation, right? And lean manufacturing is the preset of it. Industry 4.0 basically talks of how smartly and efficiently you can cover a particular set of work, ensuring your folks are being trained on a multidisciplinary activities. Whereas lean manufacturing sets the aside, right? It particularly sets a particular functional bed.
Thank you, sir.
Thank you so much, sir. Thank you, Yashika. I would now request Dr. Sandhya Makkar and Dr. Balram Tyagi to kindly felicitate Mr. Abhishek Nag with a memento and a certificate of appreciation.
Professor Makkar, good to see you after 9 long years.
now request Professor Balram Tyagi, seminar to kindly deliver the vote of thanks. Please, sir.
A very good afternoon to and all of you. On behalf of LBSIM and on my behalf, I convey my deep regards and heartfelt thanks to our esteemed speakers, Professor Arindam Pal, Professor Ravinder Singh, Professor Rippon Chakravarti, Mr. Bohitesh Misra, Mr. Abhishek Nag, for their presence, for accepting our request for delivering this delightful and very thought-provoking address. I would also like to express my gratitude and thanks to Honorable our Professor Praveen Gupta, Director LBSIM, for his invaluable support and constant guidance. I'm extremely thankful to my colleague Dr. Sandhya Makkar and Dr. Rajkumari Mittal for their untiring effort to organize this and to make it a successful seminar. My thanks are due to Colonel Ajay Sood and his team for making all these arrangements to make it a success. I also thank IT team, Eminent Cell, Management Grid, and all students of organizing committee for their untiring effort, support, and dedication for driving this seminar. I'd be failing in my duty if I don't thank you all, the audience, who gave a patient hearing, and I'm sure that you have benefited from the discussions, from the thoughts, and you might have more questions, and that is basically the purpose of any such seminar. Thank you once and all. Thank you.
Thank you, sir. Thank you, everyone, for being a part of this seminar. Now, I would like to inform all the students that the refreshments are being served in the cafeteria, and after which classes will continue as per the schedule provided. Thank you.